Hello, Michael. Today I'm going to take you through a quick method of creating a structure based on an EtherCAT terminal, and this will allow you to quickly do your symbol linking. This doesn't work on all terminals. It's not the case it doesn't work on it, it's just the option is not available. So this generally is only available for cards which have got complex data structures behind the scenes. So jumping straight into it, what I've done is I've added an EtherCAT master and an IO link master. Inside the IO link master, I'm going to bring in the Baloff Smart Light. And secondly, I'm just going to add just an IO terminal, just so we've got something there as well. So we've got 1 and 2. I'm just going to save this. Generally, I do a build. Build Alt FS, Control Shift B is a quick way. So typically, I'm always building, just to make sure everything's okay. So what we can see here is it's from module 3 onwards, it's now started to bring in the smart light and also our IO terminal just down the side. So it's all of these, we want a method of quickly assigning these in the PLC program so we can make nice, quick, reusable code, rather than using the individual link tos. Now, a way to do this is it's slightly different in IO link because with this, it has to be at the EtherCAT side that we do this operation. So if it was a standard encoder interface card, you would go on to the EL5 blah, 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 blah terminal to do this. In this instance, because they're all IO link, we need to go onto the IO link master to do it. So what I'm going to do is select the box, and then we have this tab up the top here called PLC, and we can actually force it to create a PLC data type based on the PDO images that we have down the side. That's the first one. If we just leave that ticked, then this will make a structure which contains everything. That's both the light and the input channel that we imported. Now that's not ideal because we want to make reusable code, and therefore maybe we just want that structure to be part of a Baloff light object. So what we do is we actually force it, and you can see here it had this number. We actually force it and say we want this to be done per channel. And now it gives us the option. It says, well, I understand what 2 of these things are because we've configured 2 of our ports. And if I select the first port, this is the newly formed structure that is made behind the scenes. And we can now use this in the PLC project. We can select 2 as well, and it shows us what it's made for this one. The other thing is, just a note about this box, is both of these exist behind the scenes. So if we were assigning 2 variables to 2 bits of kit in IO Link Master, you do the first one here, you select the first and then link it to the PLC, and then likewise you go on to the second, link it to the PLC. They both exist behind the scenes, it just shows you only one at a time. Okay, so we're going to take number 1, and all I'm going to do is say copy. It just does a string copy on this value, just to make it easier for us. I've just made a GVL IO, just a global variable list, and what I'm going to do is say smart light is going to be equal to this one here. Now you can actually see when we build this, our standard error message just saying that we've got nothing linked. We've got EtherCAT terminals, but nothing linked in the PLC program, so that's fine. What you actually see is I didn't have to use the at symbol at all to define at ins or at outs, because that's all taken care of in the structure itself. So what this will allow you to do is you can now see in external types, it's actually brought forwards the structure that's behind the scenes of this. And if we open it, we can actually see here's the at I and the at Q symbols. So just to prove that we can now use that, we go back into the IO Link Master, and this linked PLC, it now shows us that we've got GVL-IO Smart Light. Now that will do all of the I and the O. It does the whole thing. It does the mapping to the structure for you automatically. So I think just off the bat, that's probably solved what you're looking to do in a nice way. I'll carry on with the video slightly longer, just to show the next stage, really. But hopefully that's already answered your question. So what we're going to do is say, yes, I want that to be assigned to here. So that's our smart light. The next thing to consider, the actual naming of this, I have seen that it is known that this naming can change based on project, based on your PC. I've not had confirmation yet behind the scenes where this number actually is generated from. And I have a funny feeling that this isn't something which is set in stone either. So one of the issues being is, let's say we wanted to make ourselves an object that now encapsulates this structure. If I was to make an object, and I tend to use T notation for objects, so T smart light, and it's function block, and it's the smart light itself that has light is of this type. I'm just going to compile that. What you can see here is in our instance now, we haven't instantiated the object yet. Let's just go into, we'll say that main owns it this time. So just to show that we can do this anywhere. So this is my status lamp is going to be a T smart light. Just compile that. So we'll get an updated now main instance saying that we do have two variables now, which cover all of these I/O, and we can see this this one here. So it's got everything inside it. If we go back to the terminal itself, link to PLC, we can now see that we can assign it to two different things. We've got two symbols that are valid. Also as well, before I go further with the object, just to show you how you would use the status, we can use smart light. Because I've got qualified only on, it means I have to type in GVLIO. So if I go into main and type in GVLIO dot smart light dot, and now we've got access to its inputs and outputs. So if we just go to the output, and now we can do things like buzzer state, type, volume. So it's given us access now to all of those variables that you were trying to link to in the first place. So it's exposed all of those. Granted, they are long symbol names. So this is one of the things that comes with the automatically generated structure. It tries its best to make the naming from it, but with it you get a complex name. So if we were setting, for example, the operating mode bit 0, we could then just say true, and then just make sure that compiles okay. There we go. So that just proves that that's all fine, that's compiled, that'll actually run, and that is the inbuilt automatically generated structure that is now linked to that lamp. The next thing that I would say, so going back to our smart light, this one here, I'd prefer not to hard code the name of this, just in case we have any issues where this name disappears or changes. So I'd much prefer that to be quite descriptive as well, because then again, in MDP 5001, it's not very descriptive. So what we can do is go in and say that we want to add a new structure, DT, and we're going to, let's go, we'll just call it Battle Flight for the moment. I was going to do it the part number, but that would involve me dropping out and copy and pasting again. BA Battle Smart. We're just going to do a structure of Battle Smart Light. So that's now our structure, and we now have ownership of this. We can maintain it ourselves. What we can do is go into these external types, and we can actually lift the inner content of the structure out. Well, actually, I'm going to lift the inner content of the structure out. So this part here, and I'm going to go in and paste into my structure. I'm just going to paste this in, and actually get rid of the duplication. Let's just make sure I've done that right, because there we go. Let's just copy and paste that there. There we go. Right. So I've pasted the inner side of the structure out. The second thing that I want to do, and what you can see here is the minute it knows that you are using these, it starts bringing in the next parts. You can see here, this is also auto-generated, the ins and the output structures. So we'll get to that slightly more later. So going back to the main one, I'm also going to bring in that attribute here too. So that lives above. So all of these attributes are tied into what the lamp tower itself will then accept as a valid structure. So I'm just copying those across. So if I compile this, and I'll just have to change my object to, so DUT smart light, I'm going to say is actually using a DUT smart light instead. What we can now do is go back into our IO link link to PLC, and you can still see here it's still presenting it saying this is a valid it's a valid symbol. So we can say that actually now we have our own structure. Okay, it's got generated code inside it, but it's still becoming our structure now. The next steps that we can do is obviously that long file naming. We can now say, well, actually, because it's under our control, I want this to be just in, and I'm going to make this one just out, and we'll save and compile this, make sure that there's no issues. We won't keep linking information just because things have now changed. We will have to remake it because of structure. Okay, so that's now changed the naming of this, and just to prove again, if we go back into the PLC, link to PLC, it still sees it as a valid structure, even though we're now starting to come away from the naming of the original. Because it's laid out in the same way, it will still accept it and class it as a status line. I won't link it just for the moment because we're going to do some more modifications. So that was our Baloff Smart Light, and we've now just tidied up the in and the out. So if we were to look at this inside our object and just say my light dot, I've just got in and out now. That's already shorter already, so let's just go out. But again, we've still got these huge file name, symbol names after this, so let's now correct these ones as well. Let's just get rid of that for the time being. It's nicely given us access to these inner symbols, and now you can see how these have been internally created too. So what I'm going to do is make new DUTs for these. And I'm going to say this is a DUT Baloff Smart Light. We'll go with the we'll go with the in to start with. So structure in. For this one, pick the in structure. And again, I'm just going to take the center of the structure out and paste it into our own. And the second thing I'm going to do is just lift the top GUID out as well, just so that the lamp tower is confident that we are obeying the correct structure. This one here. Now we can start shortening things too. So I'm going to say, well, actually, this is just error. Maybe even shrink it down even further. So this is error bit 0. Say that this is error bit 1 and this one is error bit 2. The rest are reserved and they're already attribute hide, so that's tidy. I'll save this, and the next step we need to do is this DUT Smart Light in. We need to change our main structure now to point to our version of that instead. Let's just compile, make sure we've got no compile errors. And again, the main test to make sure that you've not done any typos and everything is okay is because when you say link to PLC, it will still remain in the list as a valid symbol that you can link the PLC. The minute you do something wrong or you don't bring those GOIDs in, it doesn't believe it's the right type, and therefore it just won't allow you to select that symbol. Okay, and then let's just do the last one just for completeness. So we will do add DUT. So we're going to go DUT. Out and open up the app versions. You can actually see them starting to drop away now. When we no longer use them, they will disappear. They will start to hide themselves and tuck themselves away. So I'm just going to pull the center of this out. This is the output structure, and follow it with the attribute GUID. The nice thing with this is obviously it's a little bit of work just to do up front, but once you've done it, then you've got your Smart Light structure already there, and now you can reuse this as much as you like. We will just correct a couple of these. So background color LED. Again, I don't know these very well. Let's just pick something easier. So buzzer state, we'll just reduce that down to buzzer state. Okay, there we go. And compile. That compiled perfectly. And then the last thing is take out the out and go into our Smart Light, and this becomes the out. There we go. Now I'll go back into our link to PLC. It's still there as valid, so we can OK that now. So that's now a perfect link to the PLC. The next thing, so we're now running with this Baloff Smart Light. It comes with its own structure. And these external types will now start disappearing the minute I start, well, as soon as I no longer need them again, they won't hang around. Is no structured variable. Let's just get rid of that as well. Just tidy up the code. Okay, no errors. Good. So what we've done is we've removed all external types now. We've successfully extracted the structures out of the auto-generated structures, but most importantly as well, we've captured those GUIDs, which allows us to assign our own structures now to these blocks. And you can see there it's still valid. This is good to go. And then really, I've shown that there as a smart light, just as an object. You can now do things, you can now start doing like real encapsulation of this, because obviously one of the things that you don't want people to do is to know too much about your structures and maybe not know too much about your objects. So let's say we just wanted to say switch all lamps off, for example, just a straight method on this object. We can make that public. Switch all lamps off. Because we've got access to the structure inside, let's just tidy these up as well. We've got the light itself. That is the thing that has just been tethered to the I/O. This light here, switch all lamps off. We can actually say light dot output dot, and let's just pick something. We'll just pick one of the colors, and let's just say we set that to 0. This is only just it's just a false. This is only just a made-up example, but let's say there was some logic in there that you had to tweak and push and poke that structure in order to make everything switch off. Ideally, you'd want to encapsulate that into a nice method of switch off all lamps, or switch lamps all off. And then in main, it becomes as simple as saying, well, my status lamp dot switch off all lamps. There we go. And your code is nice and easy. No one had to know what the structure was or how to use the structure. And plus, you can now put this into a library of your own things. And if you build up this library, it just means that coding becomes easier every time you do a project. Just to show how reusable this is now, if the customer was to then say, actually, I want 2 lamps on my machine, we could say, and this one's maybe just an error-only lamp that you're using it for. We've got 2 smart lights now. The minute we save and compile that, in our I/O allocation, you will see that it's now made 2 versions of it. Perfect. It's just brought the structures in. The I/O allocation is already being prepared for you. And it comes with some really nice namings, because you now look and say main.statusLamp or main.errorLamp. Perfect. If we go into our I/O link and say, actually, number 3, we're going to say, yep, we've just added a new smart light. We're going to put that onto number 3. I can now go into my PLC slot, keep my status lamp on number 1, but in number, sorry, let's just make sure we do a build solution. Okay, and then select number 3, and it's saying that currently it's empty. There's no one who's dealing with 3. Who can we link? You can now see that we've got an error lamp that's available to it, and we can assign it to that. So we can now save this. Should we do a save? Final build, rebuild solution. And we're good to go. Okay, I hope that answers your question. Like I say, you can't do this on just standard I/O terminals, and just to prove the fact, let me just make this video go on slightly longer by putting in an EK1100 bus coupler, and then we're going to drag in something like a standard 8 output channel. What you see here, if I go onto the output channel itself, each one of these are just, as you'd expect, just those process status, and there is no PLC tab, so there's nothing to map all of those directly to a structure. But if you were to do something, one of our more complex terminals, let's just put in something else, like maybe one of our communications terminals I'll go for. And let's just put in something like a can open slave. Hopefully. Yep, we've now just had the PLC tab come up, and again, the ability to make the PLC data. And what that will do is then, okay, there's not too much in this one, but that will then map that data for you. Okay, any questions, let us know. And otherwise, good luck with your project, and I'll speak to you soon.